So I will start. I expect that most of you knows that YaST was converted from YCP to Ruby. YCP was open source, but proprietary used only for YaST, so it's a really limited language that we need to maintain. There is many benefits for developers, but I want to talk here about benefits for users, especially YaST users, and show that there is some connections between benefits for developers and for users. Probably first thing you may notice is that the conversion is almost without bugs. We do not add any, I think just 2 new bugs that we fixed. Of course, all the bugs in YaST doesn't disappear, so it's still there, but we do not increase the mess. Okay. So the first thing is that happy developer means that user win. Probably you know that YaST is mostly developed by SUSE developers. I think currently it's almost only by SUSE developers. There's almost no community members. And it's not much fun to write in old YCP, and what's worse, if some developer goes to other team or left company, then it's not so easy to find new developers because no one outside of YaST team knows YCP. And also what I want to say with happy developer, if developer is really dissatisfied with the language and with the code, he can left even if SUSE paid him. Money is not everything, and sometimes developing YaST is really pain, so we try to minimize this pain, and it means that user win if we can attract new developers both for SUSE team or the community one. It means that YaST will be better and less bugs, more features. I touch it also in next slide because Ruby is known that it allows quite fast prototyping. That's quite opposite to old YCP, which is quite formal. It have types, it have some well-defined structures. It's not so easy to just start coding. You need to create some structure to start. In Ruby, it's quite easy. I will show it on the workshop this afternoon about writing new Ruby module. Just to get impression in Ruby, in pure Ruby, it took me around 2 minutes to create module that just show some button and do something just as a start and just to start for a workshop. So it's really fast, and in old YCP always took me some time because there's some other stuff that's not so elegant like auto tools. That always makes me pain because it's not much intuitive language M4, which is used in auto tools. So, as I said, it's again less bugs because we can quickly fix it, and also more features because we can write it more quickly. The next step that's change for user side is exceptions, because old YCP doesn't have exceptions. It always uses the return code. It's similar like old C. In C, you always return bad states in return code, and sometimes you set some error number and so on. But the main point is that if you want to check if something goes wrong, you need to explicitly check the return value. And if you forget, then you continue and probably it breaks later. Or what is sometimes worse in YaST, it doesn't break at all. So it means, well, everything is fine, we just finish setting, and then you try it and you see it's completely garbage, and you say YaST doesn't work, and maybe it's not true, maybe it's just some small bug that breaks something, but you don't see it. With exception, the situation is opposite. You raise exception, and if you forget to catch it, then it goes to top level. And in YaST, there is top level catcher of exceptions, and it shows some red window. There is internal error, some exception goes. So you really see that something is wrong. And it have one more nice benefit. It's integration with OpenQA. Because in OpenQA, you do some settings in installer, and then do some other tests. And with old code, you just do something, and it's not so easy to verify that it's really correctly set. You need to manually verify that all software is installed, everything is set up as expected, it's correctly localized, and so on. But with exceptions, if we do not catch the exception and handle it somehow, then it shows the red window, and OpenQA saw, hey, there's a red pop-up, we don't have it usually, so something is wrong. And that's the time when Kulo sent me email or pinged me on IRC and said, well, something is wrong, you probably broke this module, so we do not accept it. It really helps with catching errors. And the benefit for user is there is no hidden bugs if we use exceptions. Of course, when we convert the code, we want to behave the same. So the old code still use the return value. But if we change something and there is a problem in Ruby, then it raises exception and we see it. And we start to use it quite a lot, exceptions, just for this benefit. Well, other benefit is that Ruby is quite well known. What it means. For YCP, we write the language ourselves. So we must maintain it. And to be honest, there was some bugs, and we found it when someone new comes to the team. I think Michal Filka joined the team 3 years before, and the result is then he tries some features of YCP and it doesn't work because there is bugs. Some is quite serious that can cause the seg fault. In Ruby, this situation is different. Ruby is used for many projects and it's used quite heavily in web development with Rails. So the number of bugs are really slow in the core library, and it's really good tested by community. Before every release, there's a lot of guys that try it for their web pages. So there's less bugs in the core library. And that's the benefit also for us, that we can focus on the modules and we do not focus on developing language, which is quite nice advantage. It also means that we can attract more developers, because when we now hiring a new guy for YaST team, we can say we need someone who knows Ruby. In the past, we cannot say someone who knows YCP, because we do not hire anybody. Maybe some old YaST hackers that left the company and want to rejoin, but that's a really smaller group than Ruby developers. And we also hope that it attracts some community developers, because community often want to learn something. And if we offer him learn YCP, it's a cool language, but you don't use it anywhere, it's not so nice. Like if he said, hey, do something for YaST, and we learn you how to write nice Ruby code, and then you can use it for your web pages. Many companies hiring people with Ruby knowledge, and it can help you in the future. And last but not least, if YaST won't be sponsored by SUSE, if SUSE decided to stop sponsoring YaST development, there is bigger chance that community can take over the project. Because Ruby, it's enough if you know how configure a system. You don't need to learn another language. So we minimize the obstacles for development. It's quite interesting part that there is some language is one part. You have some language. It can be better, worse. It can be more native to write in it, or it can be some strange parts. But what makes the programming language good is the ecosystem around. If you have language that's perfect, but you don't have a debugger, you don't have profiler, no IDE, if you don't have runtime support, more libraries, then that language is almost dead, because it's just language and nothing more. And for YCP, I think it took 10 hours just to write debugger for such language. That really quite horrible. And with Ruby, we get a lot of this stuff for free, because we are not the one who must write it. So with Ruby, we have Ruby debugger. There is a lot of profilers that allows us to optimize a code. I can say to you the story that we get some bug report for bootloader that it took 8 hours to install boot code or a whole installation, but the booting part that took 8 hours in installation. And customer slightly complained that it's not so nice. And it was really hard to debug it, because I need to check the logs and see the differences. Well, this function is run at the morning and this is at the evening, so what happened before? At the end we found that we do some stupid logging with disk, and this machine have, I think, 10,000 disks. So it's slightly special, but it's a real pain to debug it. And with Ruby, you have the profiler. You can set the customers, I have this suspicion, just run this command and see how long it takes. Or you can integrate it profiler, so generate some report and send me, and I see what functions take so long. Also, what have the Ruby and YCP doesn't have is interactive shell. It's IRB, maybe you know it, that allows you to write some commands, and I often do it with supporting some guys that I need to check something, so I set type IRB and run these 3 commands, and it shows you the result, so I see what's happened. For YCP it's quite hard, and you need to write some special client and run it in a special way, and then attach logs, because everything from YCP is written to log. There is no direct output. So it's a really big improvement. And what it means for users, this infrastructure, again, easier debugging, so it means faster fixing bugs, and also improvement of the code. That means, for example, speed improvement. If you complain that some modules took ages to write something, then we can look at it, and it's much easier to see where is exactly the problem. Well, sharing code is quite big topic, because there's much products, even in SUSE, that can benefit from YaST code. YaST lives for a long time, so it handles many corner cases. Like there is some special disk that needs some special bit set up in its fancy table, or there's some ThinkPad notebooks that have some specific MBR section, or things like that. And YaST already contain such code and handle such situations. So if you need it, then you want to reuse this functionality. And with old YCP, it's not so easy. We do some attempts with exporting via parallel, via dbus, but it's not so easy, and there is quite a lot of bugs because it's another layer. It's just layer above common YaST code. Even YaST team goes into such troubles because we want to reuse functionality between YaST and WebYaST. And there's a lot of bugs in the layer between because we do not call directly YaST but via dbus, and it's not so easy. So with Ruby, it's much easier to share code. You can create module, it has some nice functionality. You can set, well, maybe someone else can reuse it, so I create from it Ruby library that's used from YaST module, and this Ruby library can use also the other people. We already use it for registration, which is not so interesting for OpenSUSE part because you don't register OpenSUSE, but we hope that in future more modules will be available as library that can be reused. And again, the benefit for users is if the code is used by more users, by more product, it means less code, more time investment in it. That means also the faster code. Some features can be implemented by other team because they need it, so you can get almost for free in YaST. And that's help especially us as YaST team because we are quite small team, and there is some other teams that are bigger and can help us with this task, with improving the code, that configure stuff. Yeah, and the last part is performance. There is some discussions on YaST Devel mailing list or OpenSUSE Factory when we announce conversion of YaST, that wow, that's Ruby, it's slow, it's took the gigabytes of memory and many other stuff. So what's the result? We do measurement only for memory because that's the most interesting stuff for us, because we have a requirement to allow graphical installation in 512 megabytes. So if you have notebook with such memory, you can install it OpenSUSE in graphical mode there. So we measure it, and there is a slightly increase of memory footprint, but it still fits into it. And code is not the biggest part. Usually the most memory takes in sys, which lives in a RAM, and there is some images and so on. So that usually takes the most of the RAM. In, I think it's 300 megabytes to use the images and some style sheets and such design stuff in graphical installation. And performance from the time side, I think feedback is mostly that no one see the difference. And if someone sees a difference, it's mostly the positive one. So it means that YaST runs faster. My suspicious is that it's caused by memory management, because old YCP, when you last use the some structure, it's immediately removed from memory, but Ruby do it in steps. So it means it just run, and then clean all stuff that's not needed. So I think that for some parts there is quite a lot of allocation in the location. It can speed up things. Of course, the other side, it's like increased memory size, because you just allocate, and then delocate, destroy it in one step. And maybe one interesting part, why is performance important for OpenSUSE? If OpenSUSE wants to replace Windows XP, that's expired now, then I think it's perfect case if someone have machine with 512 megabytes RAM, because the next Windows is Vista, and it's almost impossible to run it on such configuration. I think even 1 gigabytes of RAM is quite pain, and my notebook have 4 gigabytes, and sometimes I still feel that the performance is not great. So that's reason, and maybe we can somehow propagate that for such machines. It's OpenSUSE a good replacement and can help users. Maybe we can increase our user base. Okay, so that's everything I want to say you. Here's some contacts for YaST team. If you are interested in anything or have some questions, feel free to ask on IRC or mailing list. We are quite actively responding there, so there's almost always someone who writes to answer or say who is the right person from team can answer you. So thanks for your attention, and is there some questions?
What has happened to this infamous YaST log thing you always attach to all YaST logs, bugs?
Yeah, logs still live. The reason is that we convert the code, and our goal is to don't rewrite a code, just change the language of implementation. So logs are still there. We have some stuff there, and I think our intention is to write the interesting stuff for users in UI directly, and in logs have just some internal ones. So if there is some error, like that your file have broken syntax, I expect that YaST should write your file is broken, you probably manually edit it and break something, and do not hide it in log. But currently it's evolution. We do not make a revolution that we said throw everything and write it from scratch from Ruby. It's almost impossible. So we just convert old code. It behaves exactly the same as like YCP, and we just start when we touch something. We try to improve it and use benefits of Ruby. So logs is still there, and you should attach it to every bug. Okay, some more questions? Yep. Okay, so thanks for your attention.